So, our first team presenting is Infinite Chemistry. CC student team members presenting are Prakar Gautam, Paul Price, and Nicole Chaney. Additional team members not presenting are CC students Pietro Giacomin and Kochi Nakajima. Please join me in welcoming Infinite Chemistry.
Good afternoon. I'm Prakar. This is Nicole. There's Paul. And we are Infinite Chemistry. Chemistry is the study of everything that we know of and most of what we don't. It's that subject that's got our team's interest, and we think it'll get yours. We're CC students who are using virtual reality to update chemistry's 250-year-old teaching model for students, researchers, and professionals. I'm a biochemistry major at CC. And I've spent the last 3 years doing chemistry like this. I've learned a subject inherently about 3D shapes and molecules in 2D through a piece of paper. From Chem 1 to Organic Chem 2, I've been forced to learn how to visualize complex reactions that are occurring in 3D space on a piece of paper. My fellow classmates, who are future scientists and doctors, are also forced to use this archaic model of learning that prohibits effective scientific research from occurring. Having to visualize these tiny particles on a 2D plane has made chemistry way more inaccessible than it needs to be. That's where Infinite Chemistry steps in. Why should we teach chemistry like this if we can do this instead? My team has created a virtual reality software that allows users to upload, visualize, and manipulate molecules in a 3D setting from any chemical database online. Not only that, they can upload multiple molecules to see reactions occur right in front of their eyes. And no, we're not going to stop there. That's way too easy for us. We're going to incorporate all of the higher level abstract concepts taught in higher level chemistry so students never have to be limited by an archaic model ever again. So who is Infinite Chemistry? We're 21st century students who are to provide a 21st century solution. Our team is here taking on this challenge. I've done months of research, understanding, and working with 3D molecules. 3 of my teammates are software developers who each bring individual leadership experience to the team. Paul has successfully run a charity for several years. Pietro, over there, has experience working on a startup from last year. Kochi is the winner of several work grants and has used them to help revitalize the Springs community. Nicole currently works at CC's IT department and has used her knowledge of the tech sector to help build our financial projections. We have 4 very strong advisors on the team, 2 of which are giving us their financial advice to help build our startup experience. And the other 2, they've helped us combine chemistry, physics, and code to create the engine necessary for our software. Now over to Nicole to tell you more about the features of Infinite Chemistry.
Thanks, Prakar. So what are the applications of this software? Here's a story to put it into perspective. In the early 1980s, scientists discovered one of the first drugs that was helping curb cancer. This drug was so effective that the cure rate for testicular cancer went from 10% to 85%. At the same time, scientists were unknowingly creating another version of the drug that didn't have the same life-saving effects. Scientists spent years trying to solve this problem. Why was it that one form cured cancer and the other seemingly identical molecule didn't? They later discovered that it was because of the shape of the molecule that it affected how it interacted within the body. This problem was derived from the pen and paper model, not being able to truly show the way in which drug interactions work. If Infinite Chemistry had been around, scientists would have been able to get to that conclusion just a little bit quicker. We spent the last summer creating our prototype and developing a relationship with CC's chemistry department. Already, we've done more than 50+ student trials, and we've been approved to use our software in CC's advanced inorganic chemistry class this month. Through these student trials, we've discovered that students prefer working with molecules in a VR environment rather than with the pen and paper or with the mouse and keyboard. But this isn't just about intuitive learning. It's about creating an environment in which students are able to work. We want to help deal with the world's biggest challenges, like climate change and medicine, in a modern way. To do so, we plan to equip people with the tools and technology to make the invisible molecular world visible and make collaboration simple. Infinite Chemistry provides a shared environment for labs, students, and professors. Scientists and other professors can meet in the same virtual space and do research together. By providing a singular and unlimited storage space, our software will become the next Dropbox of chemistry. Moreover, we complete our reactions with code, not with chemicals. That means reducing the damage done to our environment by the 5 million tons of lab chemicals dumped down sinks every year. Infinite Chemistry is clean, collaborative, and a tool for solving all of chemistry's biggest problems. Now here's Paul with our financial projections.
The education industry has witnessed dramatic change over the past few years, but man, has it been slow to catch up. The advancements seen in technology and innovation are rapidly changing the market scenario and are increasing the need for cost-effective educational tools, which is why Infinite Chemistry will be able to grow in the VR, research, and edtech software markets that provide a $25 billion opportunity by introducing that cost-effective solution. Our early adopters, such as educators and professionals, will work side by side with us as we conduct user trials so we can hear what they want to see in our software. Infinite Chemistry will run on a 3-tier monthly subscription model. The first being Hobby Chem, which is a free service that we'll provide because we believe getting people interested in chemistry is the most important thing that we can do. Our first paid tier will be Infinite Chem. This will mainly be for educators and will allow for customizable lesson plans that these educators can create so they can tailor their individual classes to their students' needs. Infinite Chem Plus is for professionals and researchers. This will allow them to do real-world experiments on our virtual reality platform. Not only that, but it allows for the complex reactions needed by cutting-edge researchers today. Infinite Chem Plus will be the new industry standard. This is our roadmap for the future. Currently at the Big Idea, competing for initial funding. With that, we plan to go out and develop more so we can release Infinite Chem in the year 2020. With the traction we gain from that, we're planning on going out, competing even more so we can raise more seed funding for Infinite Chem Plus's release in 2022. We're projecting to see our user base grow from a couple thousand users to over 50,000 users in just 5 years. That would show a return in revenue of over $7 million. These numbers aren't based off of nothing. They're based off of other edtech software startups, such as Everfi, which within 10 years were able to grow their user base to over 7 million users. However, we do know we're not alone in this venture, but we do know what separates us from the competition. Here's one of them, a model kit. This allows for the 3D representation of a molecule structure, but that's all it's capable of. And our 2 other competitors, this is all they can do too. Infinite Chemistry's prototype has already caught up to the competition, and our future is right now. We're currently developing an engine that would allow for those complex reactions needed when 2 molecules interact, so we can help chemistry take its next step into the future. Which is why our ask will be for $25,000. 70% of this ask will go towards software development. That would include preparing our second prototype for commercial release, also renting out cloud computing services and integrating user feedback. The rest of the ask will go towards marketing and networking as we go on to publish a research paper later this summer that we will present to science conventions around Colorado. But we're continuing to build the Infinite Chemistry community through public and private partnerships. UCCS, Pikes Peak Community College, and UC Boulder are all wonderful institutions that we're working with right now to complete beta tests on our software. Private partners, such as Accenture, have been providing us the resources we need to complete the development of Infinite Chem.
Silicone is the rocks that make up our homes. Oxygen is the air that we breathe, and carbon is the blood in our veins. Life and everything in between is chemistry. It's the smallest things that make the biggest difference. Infinity starts with us and with you. Thank you.
Yeah, I'm going to go first. Is this on? It is, yeah. Thank you. It was lively, it was engaging, and very articulate.
Thank you.
how do you know that you have the right price for infinity chemistry and then infinity plus chemistry? In other words, how did you back into those prices? I noticed at one point in the material that you were charging $10 for the hobby and decided against that, and I think that was very wise. But if you could just share with me your discoveries in terms of pricing.
Well, as we know, currently there's a software called Mathematica that has reached out to thousands of institutions around the US. And their pricing has been kept around similar to ours at about $100 per month on a subscription model. But the reason for that is so we can keep a sustainable business growing, because something like chemistry doesn't stop expanding. So in order for us to keep up with something like the science of chemistry, we need to be able to update the software and have the resources so we can continue to work on it. So that is why the prices are at that rate. We've done a lot of research to also look at other edtech software licenses, and they all tend to keep that general price because it's really important to keep that sustainability going in order to provide an updated software that will continue to work as chemistry changes itself.
My son said he can't get into the lab for Orgo because they don't have enough spots in the lab. Would the virtual reality allow a little bit more flexibility on that and allow more people to come into the lab at CC and other places?
Well, something that's really big that we're working on right now is not only providing Infinite Chem for a fully powered desktop computer that can run the up-to-date Oculus or HTC Vive, but we're really planning on scaling this program down so it can even be run on something such as a Google Cardboard, which is very inexpensive. So by allowing to do that, this would really give many people access, especially through a free product like HobbyChem.
Cool.
With the researchers that you've already met with and spoken with, what are they most excited about, and what are some barriers or some hesitations that you've seen from researchers that have been doing chemistry research for a long time?
Thank you. That's a good question. One of the things researchers really need is understanding molecular interactions, let's say inside the brain. So drugs, recent pharmaceutical drugs, are put on the market, but to understand their effects in the brain can be incredibly hard, just due to the amount of time it takes to test and to understand the interactions that happen with a small molecule in a really large 3D space. So they're super excited to know and be able to do these interactions instead of having to do beta testing on people to see what it will look like in our software first, and then actually go out and have these medicines patented and put out for the public. And some barriers are the computing power requires to have something as large as the brain being active or running. So, but with cloud computing, we hope to bypass that.
Have you all talked, about what each of you wants from this? Like looking future state, where do you want to be in 5 years, 10 years? What's it going to take to get there? What's the culture? What have you guys discussed aside from the product? What have you discussed in terms of building a company around this?
Well, one of the biggest goals for us really in the future is accessibility. As we mentioned with HobbyChem, one of our most important things is to get people interested in something like chemistry. And one of the big things we currently see on the market is large pharmaceutical companies raising the prices on drugs. So for us to build a healthy company culture, it's really important for us to have an understanding of what the market's like. So for us, we have to take a step back and understand what's it like to be someone who has to pay high prices for prescriptions. Well, this is a tool that would allow for people to create new drugs at a much cheaper price. So that's kind of something we're kind of building around and focusing, is creating an accessible and affordable model that also sustains itself through the prices in our subscription fees. And that's kind of what we're expecting to see in the future. We've currently spent a lot of time just really developing the software the past few months. We've been working very hard on that. And the business model is something we're really trying to build right now and really focus so it's something that's healthy for the future and can sustain itself.
Great job. I think you, 5 of you all did a great job, and you can see everybody's got a little role, which is great. Do you feel like this will allow more people to access chemistry? I mean, you kind of talked to that a little bit, but it just learning in the 2D world, it's very intimidating, but maybe this will bring it to so many more that they may have it in them, but they didn't really know they had that ability until they see it this way.
Well, yeah, one of the most important things that comes out of this software is that being able to visualize something inside of your head isn't something you're born with.
Right.
It's a skill. It's something you have to build on. And this tool allows anyone that could be lacking in that ability to truly experience chemistry like anyone else would. And so with that, as we mentioned with the Google Cardboard, it's also about accessibility. And then on top of that, we have the cloud server, so we can create a centralized place for research data. This would then allow any of our customers to pull that data down and then experience what a professional is doing while maybe you're in high school or just a college student who's just interested in learning more.